Welcome to our comprehensive guide on microservices best practices for Java. In today's fast-paced software world, microservices have become the go-to architectural style for building scalable, flexible, and maintainable applications. This video will walk you through the essential concepts, practical strategies, and real-world examples to help you master microservices in Java. Whether you're a developer, architect, or IT leader, you'll find valuable insights to enhance your cloud-native journey. Let's dive in and explore how microservices can transform your Java applications for the better. Cloud-native applications are designed to fully leverage the dynamic nature of cloud environments. Unlike traditional on-premises systems, cloud-native apps run in virtualized, elastic environments, allowing resources to be allocated and released on demand. This flexibility enables organizations to scale quickly and efficiently. Cloud-native systems typically use containers for process isolation, central orchestration for resource management, and loosely coupled microservices with explicit dependencies. These characteristics create a distributed system that can adapt to constant change and unexpected failures, ensuring high availability and resilience. The 12-factor app methodology is a set of best practices for building portable, resilient applications that thrive in cloud environments. These 12 factors cover everything from code-based management and dependency declaration to configuration, backing services, and build pipelines. By following these guidelines, you can ensure your Java microservices are stateless, easily scalable, and maintainable across different environments. While not every factor must be strictly followed, keeping them in mind helps you build robust applications that support continuous delivery and rapid iteration. Microservices are small, independent, and replaceable processes that work together to form complex applications. Each microservice focuses on a specific business capability and communicates with others through lightweight APIs, often using REST. The key is autonomy. Each service can be developed, deployed, and scaled independently. This approach enables teams to innovate faster, adopt new technologies, and respond to changing requirements with agility. By keeping services focused and loosely coupled, you can avoid the pitfalls of monolithic architectures and achieve greater flexibility. Core principle of microservices is independence. Each service should be able to start, stop, or be replaced without affecting others. This autonomy allows for rapid updates, easier maintenance, and reduced risk during deployments. To achieve this, microservices encapsulate their implementation details and maintain private data sources. If changes require coordinated updates across services, it's a sign that boundaries may need to be redrawn. Embracing independence not only boosts agility, but also supports continuous improvement and innovation. Microservices must be resilient, expecting and handling failures gracefully. In distributed systems, network issues, bad data, or unavailable services are inevitable. By following the robustness principle, being liberal in what you accept and conservative in what you send, your services can adapt to evolving APIs and unexpected scenarios. Isolation patterns like circuit breakers and bulkheads prevent failures from cascading through the system. Building resilience into each service ensures your application remains available and reliable, even when parts of the system encounter problems. Automation is essential for managing the complexity of microservices architectures. With many independent services moving at different speeds, manual processes quickly become unmanageable. Automated build, test, deployment, and monitoring pipelines ensure consistency, reduce human error, and speed up delivery. Automated monitoring and alerting help detect issues early, enabling rapid response and minimizing downtime. By investing in automation, you empower your teams to focus on innovation rather than repetitive tasks. The structure of your development teams can significantly impact your microservices architecture. According to Conway's law, systems mirror the communication structures of the organizations that build them. To maximize the benefits of microservices, align your teams with service boundaries, encourage cross-functional collaboration, and streamline communication. This approach supports agile practices, faster decision-making, and more effective ownership of services. Rethinking team organization is often as important as technical choices when adopting microservices. To ground these concepts, let's look at two practical examples: an online retail store and the Game On adventure game. The online store uses microservices for catalog, account, payment, and order management, each handling a distinct business function. Game On demonstrates extensibility and real-time interactions using microservices for players, rooms, and maps. These examples illustrate how microservices can be tailored to different domains, supporting both traditional enterprise needs and innovative, interactive experiences. Java offers several platforms and frameworks for building microservices. Spring Boot provides an opinionated, convention-over-configuration approach, making it easy to get started with embedded servers and cloud integration. Dropwizard offers a lightweight stack with strong support for metrics. Java EE, with technologies like JAXRS and CDI, is well suited for enterprise-grade microservices, supporting dependency injection, REST-TFL APIs, and asynchronous patterns. Choosing the right platform depends on your team's expertise and project requirements, but all enable robust, scalable microservices in Java. Identifying the right boundaries for your microservices is crucial. Domain-driven design, DDD, helps by modeling your application's business domains and defining bounded contexts. Entities, value objects, aggregates, and services are mapped to independent microservices. Each service should handle a single business function and own its data. Structuring your code with clear separation of concerns, resources, domain logic, repositories, and connectors makes testing, maintenance, and evolution easier. Remember, it's better to start with coarse boundaries and refine them as your understanding grows. Designing effective REST APIs is a cornerstone of microservices. Start with a consumer-first approach, defining APIs that are intuitive and well-documented. Use standard HTTP verbs and status codes, and keep resource URIs simple and consistent. Version your APIs to allow for evolution without breaking existing clients, commonly by including the version in the URI. Document your APIs using tools like Swagger or OpenAPI, enabling easy collaboration and contract testing. Good API design ensures your services are easy to use, maintain, and extend. In a microservices architecture, services must be able to find and communicate with each other reliably. Service registries like Consul, Eureka, or Amalgam 8 track available services and their endpoints. Communication can be handled on the server side via proxies or on the client side using libraries or sidecars. API gateways provide a unified entry point for external clients, aggregating and routing requests as needed. Choosing the right discovery and communication patterns ensures scalability, resilience, and efficient load balancing across your services. Each microservice should own its data, using the storage technology that best fits its needs. This is called polyglot persistence. Avoid sharing databases between services to maintain independence and scalability. For cross-service data needs, use adapter services or event-driven architectures to synchronize and share information. Patterns like event sourcing and CQRS can help manage complex data flows and ensure consistency. Messaging systems like JMS, RabbitMQ, or Kafka enable reliable, asynchronous communication between services, supporting eventual consistency and decoupled interactions. Security is paramount in microservices, especially in dynamic distributed environments. Secure your services with network segmentation, data encryption, and automated credential management. Use centralized authentication, like OAuth 2 and OpenID Connect, and propagate identity using JSON Web Tokens, JWTs. API keys and HMAC signatures help authenticate and authorize requests between services. Always store secrets securely and automate their management to reduce risk. By embedding security into every layer, you protect your application and your users. Robust testing is essential for microservices success. Employ a layered approach. Unit tests for individual classes, component tests for single services, integration tests for service interactions, contract tests for API agreements, and end-to-end tests for complete workflows. Use mocks and test doubles to isolate dependencies and automate tests as part of your CI/CD pipeline. In staging and production, run synthetic transactions, canary tests, and fault tolerance checks to ensure reliability. Comprehensive testing builds confidence and supports rapid, safe deployments. Deploying microservices requires careful planning and automation. Use deployment patterns like blue-green, canary releases, and feature toggles to minimize risk and enable smooth rollouts. Package services as immutable artifacts, such as executable jars or Docker containers, for consistency across environments. Manage configuration externally using environment variables, configuration files, or centralized systems like Consul or Zookeeper. Automate your deployment pipelines with tools like Jenkins, Maven, or Gradle, and use infrastructure as code for repeatable, reliable environments. Effective operations are vital for managing distributed microservices. Implement metrics and health checks to monitor service status and performance. Use dynamic provisioning and auto-scaling to match resource usage to demand. Centralized logging with tools like the Elk Stack, Elasticsearch, Logstash, Kibana helps trace requests and diagnose issues across services. Templating and standardized practices ensure consistency and speed up onboarding for new teams. By investing in strong operational practices, you keep your microservices healthy, scalable, and maintainable. Congratulations! You've now explored the key best practices for building, deploying, and operating Java microservices. By embracing cloud-native principles, automation, robust testing, and strong security, you can create applications that are resilient, scalable, and ready for the future. Continue learning by exploring related publications, online resources, and hands-on experimentation. Remember, the journey to microservices excellence is ongoing. Keep iterating, collaborating, and innovating. Thanks for watching and happy coding.